Hi class, today we're going to talk about trends that we're going to see in honors physics. These trends are just relationships between two variables. So let's say you did a pendulum experiment and you changed the length of the pendulum and you want to see how that affects the period or the time of the pendulum to cycle back and forth. That's going to be a certain type of trend. You've heard about these trends, whether it's linear, whether it's quadratic, whether it's inverse. These are all things you may have heard about in junior high, or you may study later on in high school in math. These are the four most common that we're going to see in physics. The first type of trend is a positive linear trend. What that means is as one variable goes up, as you can see here in number 1, as x goes up by 1s, the variable y also increases, but they increase linearly, meaning that as x increases by 1 each time, y increases by about 2 each time. And when you graph that, either by hand or on a graphing software like graphical analysis, you'll end up seeing points that look like this on your graph. And you're just going to sketch it. You're never going to actually plot points by hand. You're just going to create a sketch of a graph, which you will either watch a video or you've already seen it, where you just draw a trend line that looks like this, a straight linear trend line. The next type of trend is number 2, where as x increases by 1, the variable y decreases. And because it's linear, it decreases by about the same amount each time as x increases by the same amount each time. So if you were to graph this, you would see points on your graph that look like this. And all we would have to do is sketch a trend line, a linear trend line that has a negative slope, a line that goes down and to the right. The next one is a no trend. In a no trend relationship, as the variable x increases or possibly decreases, you'll notice very little change to y, where it seems to go here down, stays the same, up, up, back down again. So the numbers either stay totally the same the whole time or they kind of zigzag up and down. And if you were to graph that, you would see maybe a point and then a point above it, a little below, a little above, about the same, a little below. And we draw a no trend. We don't connect with a zigzag. We just draw a line that goes straight across that shows as x increases, the variable y stays the same. The last one we're going to get into is a quadratic. In a quadratic, as the variable x increases here by 1 each time, you'll notice that y increases 0.4 the first time, then by about 1.4 the next time, then 3 the next time, and then like around 8-ish, and then around 18-ish. So the variable y increases more than the previous time. And when you get situations like this, it might be like somebody who's sprinting, where as they get faster, they cover more ground than the previous second. So you'd start to see a curve. And we would just sketch it with this curved line. So those are the very popular 4 relationships you'll see in our class. Let me just go over a couple things to watch out for. If you ever get in a situation like this, where your variable x starts with a higher number and decreases, and you look at the variable y and that also decreases, a lot of times kids will think, oh, that's because that's a negative trend because the variable y decreases. But if your variable x is also decreasing, it's actually going to be a positive trend because they are doing the same thing. So you could read it on the way up. So from 1 up to 6 for the variable x, the variable y also goes up from 1 to 6. So since they're both doing the same thing, as one goes up, the other goes up, or as one goes down, the other goes down, it's actually going to be a positive trend, and you can just sketch a line like that. And the last thing to remember isn't super common, but can happen, where you see a trend where as x goes up, your variable y just slightly keeps going up or stays the same, and then goes up, and then stays the same, and then goes up a little bit. The one thing you have to watch out for is whether that's a no trend or not. So you have to figure out your error in the experiment, which here I just set as 0.4. And your range here, if I subtract 82.4 from 82.2, is 0.2 seconds. So in this case, even though it looks like our numbers are increasing and it's a very slight positive trend, for our class, since the error is more than half the range, we would say, even though this looks like maybe a positive trend from our data table, we would still say at this time, we still think it's a no trend until we can keep testing possibly more weights. That is it. Thank you very much.